All right, this is the Geometry Semester 1 review. So topic 1 here, essential geometry. So what we want to do is we want to write what the statement here is representing and then draw a picture of it. So basically we have a P and a Q, and then we have the bar over it with one arrow. So that means ray PQ. So this is ray PQ. Okay, the endpoint P, that's the endpoint of our ray, and then we're going all the way in one direction through point Q. So here would be point Q, here's point P, and there's a ray. As one endpoint goes on forever. Okay, the bar with the two lines over it, the two arrows over it means a line. So this would be line AB. It's got the two arrows, right? And so a line goes forever in two opposite directions. So here's point A, and then here's point B. Okay, so there's a line going through points A and B, line AB. Okay, these two parallel lines tell us that the two lines L and M are parallel. So line L is parallel to line M. Right, line L is parallel to line M. Okay, so there's line L and there's line M. Put little arrows on them to indicate they're parallel. So there's two lines that are parallel, L and M. Okay, this means that J is perpendicular. That symbol is perpendicular. So is perpendicular to line K. Okay, so this is line J is perpendicular to line K. Okay, an example of that would be, here's line K, here's line J, and they're perpendicular, so they form right angles. Okay, this maybe make sure we see that this is J down here. This is line J, that's line K. Okay, really should be a lowercase J. Okay, angle PRS. So this is angle, right? PRS. Okay, and then we want to draw an angle. Right, the vertex is the one in the middle, so the vertex is R. Right, an angle is made of two rays, so one ray would be RP, and the other ray would be RS. Okay, so there's an angle. Angle PRS. Okay, this is point Z. Okay, and you can just simplify that with a dot. Okay, and this here means congruent to. So angle FHS, Fordson High School, FHS is congruent to angle DHS. Okay. And then here we could draw two congruent angles. So this would be F, H, and S, and then angle DH and S. Right, and these two angles are congruent. So we'll put one arc for both of them. Okay, so there's kind of symbols for that. Okay, recall angle pairs. Answer each question and draw a sketch. So vertical angles are congruent. Okay, vertical angles are congruent. Okay, and this would be a pair of vertical angles here, 1 and 2. Right, those would be vertical angles. Opposite side, two lines intersect. Basically opposite sides of the x. Okay. Linear pairs are supplementary. Right, so the measure of their angles add up to 180. Okay, an example of a linear pair would be, for example, angles 1 and 2 here. Form a linear pair. They add up to a straight line, so they add up to 180 degrees. They're supplementary. Okay. Complementary angles are two angles that add up to 90 degrees. So complementary angles are two angles here that add up to 90. So angles 1 and 2 here are complementary angles because they add up to 90 degrees. So add up to 90. Two or more angles that add up to 90 degrees are complementary. Okay, supplementary angles add up to 180. Okay, and then a linear pair would always be supplementary. So we can just draw an example of a linear pair here again. Okay, linear pairs have to be adjacent and supplementary. So we could have two supplementary angles here that were not linear pairs. So for example, if this is 80 degrees and this is 100 degrees, these would be supplementary, but they wouldn't be a linear pair. These would be supplementary and a linear pair. Okay, the next one, find the distance between the points 7, 5, and 9, negative 1. Then find the midpoint. So the distance formula is the square root of the change in x squared plus the change in y squared. So the change in x squared is going to be x2 minus x1 squared plus the change in y is going to be y2 minus y1 squared. Okay. So we have 2 points here, 7, 5, and 9, 1. So the x values here are 7 and 9. So we're going to substitute those in. It doesn't matter the order here, 7 minus 9 or 9 minus 7, either way. So I'm just going to do 7 minus 9 squared. Okay, plus, and then your two y values are 5 and negative 1. So 5 minus negative 1. Okay, carry down this subtraction sign, and then y1 is negative 1. So it's 5 minus negative 1 squared. Okay, so if we keep going here, 7 minus 9 is going to be negative 2 squared. Plus 5 minus negative 1, that's the same as 5 plus 1. That's going to be 6 squared. Okay, that's going to give us negative 2 times negative 2 is going to be positive 4. And then 6 times 6 is going to be 36. Okay, so our answer here is going to be the square root of 40. Okay, if we need to define that as a decimal, we could put that in our calculators. And it would probably be about 6.2 or something like that. Okay, so there's our answer. Okay, then it says to find the midpoint. So your midpoint formula, right, is x1 plus x2 over 2. We're finding the average of the two x values. Okay, and then y1 plus y2 over 2, which is the average of the two y values. Okay, so 7 and 9, you can already see without using the formula. What's halfway between 7 and 9? That's going to be 8. Okay, and what's halfway between 5 and negative 1? That's going to be a positive 2. But if we can't do that in our heads, we got to use the formula here. So our two x values are 7 and 9. Right, so 7 plus 9 divided by 2. Okay, and then 5 plus negative 1 divided by 2. Okay, so 7 plus 9 here is 16 divided by 2 is going to give us 8. 5 plus negative 1 is 4, right? That's the same as 5 minus 1 is 4. Divided by 2 is 2. So 8, comma 2 here is going to be your midpoint. Okay, maybe I should write this over here. Square root of 40. Okay, square root of 40, which is approximately 6.2-ish. Okay, so here, number 4, we have the same thing. They're asking pretty much the same question. So we're going to use our distance formula again. So distance is equal to the square root, right, of x2 minus x1 squared plus y2 minus y1 squared. Okay, our two x values are -2 and 3. So square root here, we're going to have -2 minus 3 squared. And then our two y values are 4 and -1. So 4 minus -1 squared. Right, that's going to give us -5 squared plus +5 squared. 4 minus -1, +5 squared. That's going to give us the square root of 25 plus 25. Right? -5 squared is +25, right? -5 times -5 is positive. And then +5 times +5 is also positive. So then we have square root of 50, which will be, again, approximately 7.0 or 7.1 or so. Probably 7.0. Okay, midpoint here, we're taking the average of our 2 points. So again, x1 plus x2 over 2. And then y1 plus y2 over 2. So your two x values are -2 and 3. Oops, so -2 plus 3 over 2. It's going to be a half. And then our y values are 4 and -1. So 4 plus -1 over 2. So that's going to give us -2 plus 3 is 1. So 1 over 2. And then 4 plus -1, that's 3. So 3 over 2. Okay. Right, and that's the same thing as 0.5, comma 1.5. Okay, just as decimals. Okay, number 5 here. We're going to use our segment addition postulate. So C is between B and D, so we know that BC plus CD is going to equal BD. Okay, and then we can substitute in our pieces. We know the whole thing here is 74. We know this piece BC is 2x plus 7. And we know CD here is 4x plus 1. Okay, so BC we can then substitute in. So this will be 2x plus 7 plus CD. CD is 4x plus 1. So we can substitute that in. And that equals BD, which is the whole thing, which is 74. Combine like terms, we have 6x. 7 plus 1 is going to be plus 8 equals 74. We can subtract 8 from both sides, and we're going to get 6x equals 66. If you divide by 6, you're going to get x equals 11. Okay, we're trying to find BC and CD, though, so we can plug that in. So BC here is going to be 2 times 11 plus 7. So BC is going to be 22 plus 7 is going to give us 29. Okay. CD over here is 4x plus 1, so that's going to be 4 times 11 plus 1. We're substituting in 11 here. 4x, right? So we're going to take this here, we're going to plug it in here, and we're going to plug it in here. So we have 2 times 11 plus 7, 4 times 11 plus 1. So that's going to be 45. 44 plus 1 is 45. Okay, and if we wanted to check our answers, right, 29 plus 45 is going to be 74. So we know we did our answers right. Okay, for this one here, we know the measure of ABC, so the whole thing here is going to be 63. We want to find the measure of angle ABD and the measure of angle DBC. Okay. So we can look at the first angle here. So the first angle here is ABD. So the measure of angle ABD plus the measure of angle, right, DBC is going to equal the whole thing, which is the measure of angle ABC. So just like segment addition, we're going to do the first piece plus the second piece equals the whole thing. So the measure of ABD here is 3x plus 2. The measure of DBC is, of angle DBC is 2x plus 1. And the measure of angle ABC is 63. Right? 63. Okay. Combine like terms, that's going to be 5x plus 3 is 63. We subtract 3 from both sides, so we get 5x equals 60. And divide both sides by 5, so we get x equals 12. Okay, and then we can plug in our values. So the measure of angle ABD is going to equal 3 times 12, right, plus 2. 3x plus 2, so 3 times 12 plus 2. So the measure of angle ABD, that's 36 plus 2 is 38. Okay. And then we can do the other one over here. The measure of angle DBC right, is going to be 2 times x plus 1, so 2 times 12 plus 1. So the measure of angle DBC is equal to 25. Okay, and 25 plus 38, right, so this one's 38, and this one's 25. 25 plus 38 gives you 63. All right, we have some algebra proofs here for us to do. Okay, and remember though, your final, you're not going to be writing the proofs out. Most of it will be there already, and then if the few you want to fill in, I'll have drop-down menus. Okay, so our first step here is we have 4 times x plus 3 equals 52. Right, that was given. Okay, we can then distribute the 4, so we have 4x plus 12 equals 52. That is your distributive property. Distributive. Okay, subtract 12 from both sides, so we're going to get 4x equals 40. Okay, that's your subtraction. Property of equality. Okay, because you're subtracting from both sides, so property of equality, we do it to both sides of the equation. And then you can divide both sides by 4, and you'll get x equals 10. And so we got that by the division property of equality. Okay, and we've proven that x equals 10 with an algebraic proof here. This one, same thing, basically. So you're going to have 2 times 3x plus 4 equals 56. Okay, that is your given. Okay, if we distribute, that's going to be 6x plus 8 equals 56. Right, that is your distributive property. Right, this should have been property over here, distributive property. Okay, we subtract 8 from both sides. That's going to be 6x equals 48. That is your subtraction property of equality. Okay, then you divide both sides, so that's going to be x equals 48 divided by 6 is going to be 8. Okay, and that's your division property of equality. Okay. Let me erase this. Property of equality. Okay. I think we got 2 more here on unit 1, on topic 1 here. So basically, angle 1 and angle 2 are supplementary. So actually, maybe we could type this, maybe it would be better. Angle right, and the measure of angle 2 is equal to 145. Equal to. Can't see if I wrote it. Okay. So that's your given. Okay, we know angle 1 and angle 2 are a linear pair. Okay, angle okay, so they're telling us they're supplementary. We want to prove that the measure of angle 1 is 35. So supplementary, the definition of supplementary tells us that the measure of angle 1 plus the measure of angle 2 is going to equal 180, right? That is your definition of, that this one was also given, right? And so this one down here is your definition of supplementary. Supplementary angles are 2 angles that add up to 180. Okay, we can then substitute in the measure of angle 2. So we can put the measure of angle 1 plus 145, right? Replace that measure of angle 2 with 145 because we know that's equal. That is your substitution property. Substitution property. I'm sorry, equals 180. Right? So we were given that angle 1 and angle 2 are supplementary. We know the measure of angle 2 is 145. Since they're supplementary, angle 1 and angle 2, the measure of those angles add up to 180. Okay, that's the definition of what supplementary is. They add up to 180. Then we can substitute in. We can replace the measure of angle 2 here with 145. Okay, and then we can subtract 145 from both sides, so we get the measure of angle 1 equals 35 degrees. That is our subtraction property of equality. Subtraction property of equality. We're subtracting 145 from both sides, and that gives us what we're trying to prove. The measure of angle 1 is 35 degrees. Okay. Right, next problem here. We are given that 2 times AB is going to be equal to AC. That is given to us. Okay, we have point B between A and C so that we can use the angle or the segment addition postulate. So we know by the segment addition postulate AB plus BC is going to equal AC. Okay, that is your segment addition postulate. Right, if B is between A and C, then AB plus BC equals AC. The first part plus the second part equals the whole thing. All right, we can then substitute in 2AB for AC, so we can do substitution here. So AB plus BC is going to equal, instead of AC, we're going to put in 2AB because we know AC equals 2AB. So we'll substitute this in for AC. Substitution. Okay, and then we can subtract AB from both sides. So when we subtract AB from both sides, we're going to get BC equals AB. Okay, so that is the subtraction property of equality, right? And that's what we want. AB is equal to BC. Okay, we could do another step there and switch them. Use the symmetric property there, right, to reverse those if you wanted to. But that's fine leaving it there. AB equals BC. Okay, and that's it for the topic 1 portion of the review. I'm going to do a separate video for each one. So I'll do a separate video here for unit 2.